Alright, question 2, we have three forces, and we know that a particle P is rests in equilibrium on a smooth horizontal plane. What this means is that all the forces summed together, we have three forces, right? So F1 plus F2 plus F3 must be equal to 0 because it rests in equilibrium. If, let's say, the forces, the sum of the forces is not equal to 0, then that means it will have a small acceleration. Then that means it will be moving. So it must be equal to 0. Now let's just write all these down. 3c minus 14, and then, okay, actually we have to denote something first. Let F3 equal xi, yj. So that means F3 would equal to negative F1 minus F2 from this one here. And then, which is equal to negative 3ci plus 4cj minus negative 14i plus 7j, which is 14 minus c I, and then plus negative 4c minus 7j. Yeah. The force F3 is removed from the system given that c equals 2. Find the size of the angle between the direction of I and the direction of the resultant force acting on P. Okay. So, okay, let's solve for this first. C is 2, right? So F3 would equal to, well, no, F3 is removed. That means F1 plus F2 equals, well, it actually just equals negative F3 here, so let's just copy that. So it's 3 times 2 minus 14i plus 7 plus 8j, which is negative 8i plus 15j. And how do we find the angle between all that? Well, we can draw this. We know that the direction of I is here, and then the direction of j is here. Basically just the xy axis. Let's see. This is the I vector. Okay, let me draw it better. This, and then negative 8i is like this, like this. So we have this. And then we are finding this angle. Let's call it theta. We have to, let me get a calculator. This angle is equal to this is tangent of 15/8. And then I should use pi minus, right? Yeah. So this is a bit weird, but we have to find this angle because, why? Because this angle is larger than 90 degrees, right? So that means if we use trigonometry, it would, let's say if we use trigonometry on a calculator, it would always give us the value that is between negative 90 degrees to 90 degrees most of the time. So the expression is tangent -1, this is 15 and this is 8, so theta equals to tangent -1, 15 over 8, and we get 61.93, around that value. And you see this angle is less than 90 degrees, right? And if we draw it out, obviously this pink angle is not less than 90 degrees. So what we are finding is this angle actually. So if to find the pink angle, we have to use pi minus theta equals around 118.07. Yep. Alright. The mass of P is m kg. Given that the acceleration of P is 8.5, let's find the value of m. So we have our force here, F1 plus F2. So let's find the magnitude of F1 plus F2 first, which is straight up Pythagoras it. Oops. Shit. This. Yeah. So we get 17. And that means this arrow right here is actually 17. And okay, hold up. Let's just use a big F to denote this. F equals MA equals 17. And then we know acceleration is 8.5, m equals 17, so m must equal to 2 kg. And yeah, that's quite easy actually. Well, this is worth 4 marks actually.